So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter number 5, heat. And today we are entering into the session number 3. So far we completed 2 sessions in knowing about the basic concepts of heat. So today we'll continue where we left in the last class. But before that, let us recall what we learned in the last 2 sessions. So when you can see, we started with what is heat and what is temperature, right? These are the very 2 important concepts we learned in the last 2 sessions. And so we have seen what are the effects of heat, right? What are the effects of heat? What are the source of heat? And what is the relationship between heat and temperature? Because heat is the cause, temperature is the effect. So the study of temperature is called thermometry, right? Whereas study of heat is called calorimetry. What we learned in the earlier classes. Okay, and the temperature is measured in either degree Celsius or Kelvin or Fahrenheit. Whereas heat is measured in joule, erg or calorie, where 1 calorie is equal to 4.2 joule. Relation. Right. So relation also there between Celsius, Kelvin and Fahrenheit also, that we learn in the today's session. So these are the concepts what we learned in the last 2 sessions. Starting from heat, heat is a form of energy which makes the body either hot or cool. If any body absorbs the heat, it becomes hot. When a body radiates the heat, it becomes cold. So both effects are because of the heat only. Whereas how much it is raised, how much it is lowered, that is called degree. The degree of hotness or coldness is called temperature. So because of heat only, we'll get the temperature. If you keep on giving the heat, temperature raises. Whereas if you take out the heat from the body, it becomes the temperature decreases. Right? If you see in summer, we can measure temperature raising. In winter, temperature may come to 0 or even minus also. So temperature is just because of the heat only. Heat and temperature are mutually convertible. That's what we learned. Now, today when you start today, so today we'll continue with the what are the devices used to measure temperature. Because we know sorry for that link, maybe by mistake. Today is the 6th class, only 6th and 7th. So whenever you measure the temperature, heat is measured by calorimetry, which we learn in the calorimetry, which you learn in next classes, right? Whereas, just a minute. Whereas temperature is measured by thermometer. Whereas thermometer is used to measure the temperature of the body. In last class, we just slightly started with the thermometer. What is a thermometer? How it is constructed? And today we'll discuss about the more types of thermometers. Okay. Types of thermometers, where they are used, how they are designed, that is constructed. Everything we'll discuss today as per the. Okay. So These are the different types of thermometers, names and all we'll discuss in the today's session. Okay, so in last class we discussed about what is the mercury thermometer. What is the advantage of using the mercury thermometer? Okay, and also discuss about the how to calibrate, how to mark the readings in the thermometer. So when you see the first type of thermometer we have seen is clinical thermometer, which are generally used to measure the human body temperature. That is adults. For childs, other thermometers are there, and for animals, other thermometers are there. So different thermometers are used for different purposes, right? So clinical thermometer, you can see as per requirement, as per the human requirement, we'll design the thermometer. So every thermometer will have its lower fixed point and upper fixed point. Lower fixed point is nothing but the minimum measurement you can do by using LFP, UFP. Right. So lower fixed point, upper fixed point. So in case of the clinical thermometer, you can see here, the marking starts with the 35 degrees. 35 degrees Celsius to 42 degrees Celsius. In case of Fahrenheit, it becomes maybe 92 to 104 Fahrenheit. So every clinical thermometer, because human body, the minimum temperature should be 35 degrees Celsius. Maximum should be 42. Right? In terms of Fahrenheit, 92 to 104 approx. Like that, they design and they calibrate. They mark the reading. See, you can see here 35, 36, 37, 38, 39, 40, 41, 42. For clinical thermometer, see mentioned clearly. So 37. That is called 98.4 Fahrenheit. 37 is nothing but 98.4. Or 42 is so 35 to 42 you can call, whereas in Celsius. Fahrenheit it is 98.4 to 104. Okay. So that is the lower fixed point, upper fixed point of the clinical thermometer used to measure the human body temperature. Okay. Next, laboratory thermometer. In laboratory also we need to measure the temperatures of chemicals and all when you are doing any experiment. So to find the temperature of other materials, we can use laboratory thermometer. The range of laboratory thermometer is from minus 10 degrees to 110 degrees. So minus 10 degrees to 110 degrees we can measure. Means we can measure even negative temperature also in terms by using the laboratory thermometer. Up to 110. So what is the total number of divisions here? 120 divisions. So the thermometer is divided into 120 divisions, starting from minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, up to 110. So totally 120 divisions you can find in the laboratory thermometer, and you can measure the even temperature up to 110 also. Unlike the clinical thermometer, a laboratory thermometer allows temperature as long as it is in a contact with the body. In contrast, the clinical thermometer continues to show reading even after taking away the body. This is because of the kink present in it. Kink means one string will be there. Therefore, a laboratory thermometer is not suitable for measuring our body thermometer. See, why simple? Why it's not usable means we cannot measure our temperature by using laboratory, because laboratory thermometer will show reading only as long as it is in contact with the body. Suppose we kept in our tongue or armpit, it will show our temperature, no doubt. But when you remove that, immediately it will disappear. We cannot find. Why? In that there is no clink. Whereas in case of clinical thermometer, there is a clink. Wire I told, a thin wire which raises on expansion of the thermometer, mercury. Right? The kink helps us to, even though you remove from the mouth, the temperature remains same for some time. That is the reason we use the clinical thermometer for our body temperature, not laboratory thermometer. Okay? This is clear. Now we'll come to the scales. Scales of thermometer, very important. Thermometer is measured in the various scales. Okay? various scales are there to measure the thermometer. In that, one is Celsius scale, Fahrenheit scale, Kelvin scale, Reaumur scale. In case of Celsius scale, it starts from 0 degrees to 100 degrees Celsius. Lower fixed point is 0, upper fixed point is 100. In case of Fahrenheit, it starts from 32 degrees Fahrenheit to 212 degrees Fahrenheit. Here total 100 divisions. So it is 180 divisions. 212 minus 32, 180. Range is nothing but upper fixed point minus lower fixed point. 100 minus 0, 100. 212 minus 32, 180. Whereas Kelvin scale starts with the 271, 273 to 373. Kelvin. Kelvin scale this again contains 100 division. Whereas Reaumur scale is contains 0 to 80 degrees. Total 80 divisions. Try to understand. The scales are marked. The temperature scales are marked either in Celsius. Based on that, you can measure in the units. Either Celsius, Fahrenheit, Kelvin, or a Reaumur. So, that explanation is given down. So, Celsius. On this scale, the lower fixed point is 0 degrees and upper fixed point is 100. The interval between LFP and UFP is divided into 100 equal parts. That is, upper fixed point minus lower fixed point is called range. 100 minus 0 is 100. Means total you can find 100 divisions on the Celsius scale. Each division corresponds to a different temperature of 1 degree. Second, Fahrenheit. On this scale, 32 degrees Fahrenheit is the lower fixed point, 212 is the upper fixed point. And the intervals are divided into 180 equal parts. Third one, Kelvin. 273 is the lower fixed point, 373 is the upper fixed point, and the divisions are again 100. Very, very important to know about what is the LFP, UFP of each scale and what is the difference between them, which is called range. Right. Then when you move to the next, you can find the Reaumur scale also. Right. We can see here all the table is given here. Reaumur. Reaumur starts with the 0R to 80R. 80 minus 0 is 80 is the number of divisions. See, all scales are given. Celsius, Fahrenheit, Kelvin, and Reaumur. Right? So Kelvin is given 273 is the lower fixed point. Highest is 273, 373. So how many total divisions? 100. Similarly, Celsius scale starts with 0, ends with 100, and total divisions are again 100. Fahrenheit starts with 32, ends with the 212. So total divisions are 180 because 212 minus 32. Of course, Reaumur 0 to 80, total divisions are 80. That same thing is given in the table also. The table is very, very important. Just you note down the table so that you can understand everything. Everything is given in the table only. Right? Just all of you. Note down the table in your notebook. This table. Right? Just table you note down. Temperature scale, lower fixed point, upper fixed point, number of divisions. Fast, make it fast. Write down about all the force. Then we'll see what is the relationship, how to convert one scale into another scale. So, temperature scales, 4 are there. Celsius scale, Fahrenheit scale, Kelvin scale, Reaumur scale. So, this is lower fixed point, upper fixed point. Number of divisions is nothing but upper fixed point minus lower fixed point. 100 minus 0, 100. 212 minus 32, 180. 373 minus 273, 100. 80 minus 0, 80. Here. So you have done, we'll go for the relationship conversion. Right? Okay. So after knowing that, what you can do is conversion of temperatures from one scale to another scale. For example, for you Celsius is given, asked to convert into Fahrenheit, or Fahrenheit into Roomer, or Kelvin into Roomer. How to do? For that formula is there. So this is the formula. Right? Or this one you can write. So C by 100 is equal to F minus 32 by 180 is equal to K minus 273 by 100 is equal to R by 80. Is a formula to convert the one scale into another scale. When temperature is given in Celsius, you can see newspapers when they give the temperatures of cities. Both two columns they give. One is Celsius, other is Fahrenheit. How will they get by using this formula only? What is the formula? Temperature of the scale minus LFP by UFP minus LFP. So temperature scale Celsius by UFP minus LFP. UFP is 100, LFP is 0. So C by 10 we got. Similarly, same. So suppose for you given 30 degrees Celsius, convert into how many Fahrenheit? Right? 30 degrees Celsius is given, you have to find out in Fahrenheit. So you can use only these two. No need of using this. That is C by 100 is equal to F minus 32 by 180 is the formula, because we have to convert from Celsius to Fahrenheit. So C value is given for us 30. In place of C, you can write 30. 30 by 100 is equal to F minus 32 by 180. You can cancel out 0 and 0. Right? So F you have to calculate. So bring 18 this side. So what will you get? 30 and 0 you can cancel here also. 3 into 18 is equal to F minus 32. Just cross multiplication. So 3 into 18 is 3 into 18. 54. 54 minus 32 come this side, become plus 32. Plus 32 is equal to F. So F is equal to 86 Fahrenheit. Simple. Means we are given 30 degrees. So 30 degrees Celsius is nothing but 86 Fahrenheit. Like that, you can use this formula for measuring converting any scale into any scale. Okay. So note down this total. From here to here. Very, very important this is. Okay. You note down that, then I'll give you examples for you to solve. Right. Okay. So conversion you can do like this. From here to here, no down. Or you can, after calculation, you can do like this, up to here. So this they cancelled all these things. Bit 5, 9. Very simple this is. C by 5. Finally, you can write C by 5 is equal to F minus 32 by 9 is equal to K minus 273 by 5 is equal to R by 4. Final formula. Even after cutting the numerators, you can cut them and you can get this formula. You can get 100, it will be disconnected. Write down these 4 lines. Very, very important formula for converting one scale of temperature into another scale of temperature. So many problems you come across even in IIT also. Not only competitive examination, we can find in IIT. We'll solve 1 or 2 examples before closing the session, right? By using the relationship. Right? So these are the temperature scales and their relationship. Converting one temperature scale into other. We are using the relationship here. Right? So before going for the next topic, let me give some problems based on, we'll solve. Example, we'll see. Just to come back to our presentation where you can see the suppose if you do here, I am doing one conversion here. For example, they given, suppose C is given as 45 degrees Celsius. What is the value of F is equal to how much? K is equal to how much? And rumor is equal to how much? Means 35 degrees Celsius convert into first Fahrenheit, then Kelvin, then rumor. Okay? Clear? So first we'll convert into Fahrenheit. When you convert into Fahrenheit, what formula you have to use? We have to use C by 5 is equal to F minus 32 by 9. Because we are converting C into F. So C is given as 45. So in place of C, we can write 45 by 5 is equal to F minus 32 by 9. Right? So 5 ones are 5 nines are 45. Right? So bring 5 this side, 9 this side. So you get 9 into 9 is equal to F minus 32. So 9 nines are 81. 32 minus is there, come this side becomes plus. 32 is equal to F. So 311, 113 Fahrenheit. Means 45 degrees Celsius is equal to 113 Fahrenheit. Because we are by using the formula, directly we have done. There is no rocket science here, just by this conversion. The conversion relationship we used. Just simple calculation, 5, 45. 5 nines are 45. Cross 9 will come this side, 9 into 9, 81. And minus 31 come this side, becomes plus 31. So 81 plus 32. Sorry, 32. So we'll get the 113 in Fahrenheit. So same if you want to convert into Celsius. So what is the relation? C by 5 is equal to K minus 273 by 5. Right. So you can cancel 5 and 5. Because cross multiply it will go. So C we know 45. 45 minus 273 come this side, become plus 273 is equal to K. So 318 Kelvin. So 45 degrees Celsius is equal to 318 Kelvin. Similar rumor if you want. C by 5 is equal to R by 4. Right? So C means 45. 45 by 5 is equal to R by 4. So 5 ones are 5 nines are. 4 goes this side. 36. 36 is equal to R. So when C is 45, F is 113, Kelvin is 318, and rumor is 36. Simple. Just by using the formula, we are doing the conversions. How to convert one system into another, one scale into another by using the relationship. Like that, we get so many problems will come across in the examinations, competitive exams regarding these conversions. Maybe you'll give in our worksheets also. While you are practicing, you use the formula C by 5 is equal to F minus 32 by 9, which is equal to K minus 273 by 5 equal to R by 4. Right? From that formula, we can convert any scale of temperature into any scale. So tomorrow when you see the newspaper at home, you can check the temperature of cities. Hyderabad, Kurnool, Kadapa, Vijayawada. They'll give both Celsius as well as Fahrenheit. Try to convert by using your formula. Right? So just before going for closing the session, let me show you one video on the types of thermometers. Right? Just see the video.
Hi, my name is Tempe. I am a thermometer. People use me to measure the temperature or how warm or cold something is. Thermometers come in different shapes and sizes. I have a glass tube with a bulb at the bottom that holds a colored liquid inside. This liquid will get smaller when it is cool and get bigger when it gets warmer. Temperature is measured in degrees. This little symbol, O, means degrees. There are little lines across the side of my tube that measure the degrees of temperature as a number. The higher the number is, the warmer the temperature. I can read temperatures between 0 and 100 degrees. Which temperature is warmer, 30 degrees or 50 degrees? Click on your answer. 50 degrees.
That's right, good job.
This is what a thermometer might look like in the winter. Do you think that it is warm or cold outside? Pick the clothing that you should wear when the temperature looks like this.
Hat. Gloves. That's right. You will need these to stay warm today.
Not all thermometers look like me. Thermometers come in different shapes and can measure different temperatures. Next, I'll show you a few of my friends and how they work.
All the types of
Thermometers can be found in lots of places. They are in refrigerators so that we can select the right temperature to store our food. Those thermometers measure cooler temperatures. Stoves or furnitures have thermometers so that we can select the right temperature to heat our homes. They measure warmer temperatures than refrigerators. Let's see if you can match the thermometers to the right pictures.
Good job.
Thermometers can be placed outside so that farmers can protect their crops and animals. Farmer Frank will want to know when to expect frost so that plants can be covered to protect them. It looks like it is going to be cold tonight. Click on the thermometer to see what happens.
How to even farmers also use thermometer measure.
Good job. You protected the crops by covering them.
In the summer, the temperature is very warm. Farmer Frank will need to provide shade and plenty of water for the animals. Click on thermometer to see where he moves his animals today.
Yes, that will help to keep the animals cooler.
Mechanics like Mike and car owners watch the temperature of the engine to prevent it from overheating. If an engine gets too hot, it won't run. This is Robbie, the race car. Watch what happens when his temperature changes. Robbie's engine purrs initially when needle is in blue and normal zones. As temperature gets into red zone, it begins to sputter or cough. The engine rattles and stops when needle reaches top of red zone. A parent, doctor, or nurse may check your temperature when you are sick. That is what Nan the nurse is doing. When the body gets hot, it is called a fever. Look at the two thermometers and click on the one that is warmer.
100.
Yes, good job. That's the warmer temperature.
So 100 is warmer.
Benny the baker needs to pick the right temperature for his oven to bake the bread so that he can sell it. Click on the temperatures and see what happens. About thermometers. Which of these temperatures is the warmest?
360 is a warmer. Means greater the temperature, greater the warmness.
That's right, good job.
Click on the picture of each person who uses a thermometer to do their work.
Doctor.
Yes, that's right. Who else? Yes, that's right. Yes, that's right.
Right. So, like
Good
it said,
job.
so you can see the complete details of the thermometers here and how they works and what is the scales of thermometers and what is the relationship between the Celsius, Fahrenheit, Kelvin and Romer thermometers, right? So further when you go, is the one part of the heat chapter completed where we discuss about the what is heat, what is temperature, how to measure the temperature by using various types of thermometers, right? So in this class, how heat transfers from one body to another body, how it transfers in solids, how it transfers in liquids, how it transfers in vacuum or air. That is called transmission of heat, which we'll discuss in the next class, right? So that's all for today. So thank you all of you. Have a wonderful day. Thank you.